Hello students, this is second video of last assignment of chapter 7, assignment 7.5. In previous video session we had LC oscillator circuit and some equations for the tank circuit. In this video we have transformer. So we will see principle and construction of transformer, and we will also see working of transformer, and then at last we will see one important parameter for transformer, which is called transformer ratio. So let us start. In previous chapter, we had a topic of mutual induction, in which we saw that if you have variable power supply connected to an inductor, you can see that the magnetic flux of this coil can be varied by changing voltage. And then if you have another coil placed close to it, the flux linked with the other coil also changes whenever you change the supply of first coil. Second coil shows some induction, and this induction is called mutual induction. So when you vary the supply in first, you have induced EMF observed in second coil, and this phenomenon is called mutual induction. Transformer is a device which is making use of this fact, and it is having two coils in it, just like the case in the case of mutual induction, but there are some small differences. Like in case of mutual induction, in this particular figure, whichever field lines are produced, complete flux is not linked with second coil. Okay, so there is some loss of magnetic flux, you may say. So to avoid it, the two coils, say if this is first coil and if this is second coil, if I want to link all the magnetic field lines produced by this coil, what I should do is I should have one soft iron core placed between these two coils. So what is the advantage? Soft iron core will divert all the magnetic field lines from first coil, which is in this case known as primary coil P, uh, with that of secondary coil. Secondary coil is the one across which we take output. So output voltage is taken here. Okay, so mainly three parts of transformer: two coils. One coil, first coil, is the one with which we connect our alternating voltage source. It is called primary coil. Another coil across which we take output, it is called secondary coil. And then you have iron core, soft iron core. What is the purpose of soft iron core? To link the flux produced by first coil with second one, so there is no loss of magnetic flux. Now we know that in case of induction, the applied voltage or induced voltage is directly proportional to the flux linked, or else you may say that flux is directly proportional to the induced current. But apart from that, the induced voltage also depends on the number of turns. So if I am talking about primary coil, the induction, whichever induction, because see, whenever you have induction in secondary coil or second coil, it is going to affect first one also. So induction in first coil depends on number of turns in that coil. Similarly, induction in secondary coil depends on number of turns in that particular coil. So this is one way of expressing the relation of voltage and number of turns. If we consider flux, we know that flux linked with primary is directly proportional to number of turns. More number of turns means more flux. Secondary coil, we can write this way. So phi P by phi S is NP by NS. NP is number of turns in primary coil, NS is number of turns in secondary coil. And we know that epsilon is d phi by dt. So this equation if I rearrange, phi s is ns by np into phi p. Differentiating both sides, d phi s by dt is equal to ns by np into d phi p by dt. That is voltage across secondary coil is ns by np into voltage across primary coil. Look at the equation. Very important equation. How? Because this indicates that suppose if I have a situation in which say number of turns in primary coil say np is 100, okay, and in secondary coil if I have say ns as 10. So what this equation suggests? This equation suggests that the voltage across secondary will be 10 by 100 into epsilon p, that is 0.1 epsilon p. It means that whatever voltage I apply in primary coil, in secondary I will get 10 times less. So if voltage in primary coil is say 500, voltage in secondary coil will be 50 only. It means that you can use this thing, this device, this arrangement to increase or decrease voltage. And if you are decreasing voltage, it is called step down transformer. And it can be other way also. Suppose if you take NP to be 10 and NS to be 100, then the epsilon S will be 10 times epsilon P. And then if your primary is having 50 volt, secondary coil will produce or make it 500 volt. Okay, so then it is called step up transformer. So that is all we need to know about transformer. One or two things I would like to add here. In the case of transformer, we assume that there is no leakage of flux, there is no loss of flux. One thing. Second, that resistance of these coils are considered to be very less, and we assume that current passing through secondary coil is also very less. Now, if I give this equation number 1, can we convert this equation into current equation? What if I want to find out how much current will pass through secondary coil? So we know that according to law of conservation of energy, power in primary coil has to be equal to power in secondary coil, because energy is not created in this situation, in this phenomena. We are not creating any energy. So epsilon P and IP, voltage into current, has to be equal to voltage into current. IP is current passing through primary coil, IS is current passing through secondary coil. And then if you take IS by IP, it is epsilon P by epsilon S. Use second equation in first one and see what you get. Epsilon S by epsilon P is equal to IP by IS is equal to NS by NP. Okay, so as the voltage increases, current passing through the coil will decrease. It's not that if you are making 500 volt out of 50 volt, you are creating energy. Voltage is increased at the cost of current. When voltage is increased, in step-up transformer, voltage increases, but then current is decreased. In step-down transformer, your input voltage is high, voltage across secondary coil, output voltage is less, but then current will increase. Okay, so ultimately, the power input and power output remains same, and that is called ideal transformer. Ideal transformer is the one in which power in primary coil and power in secondary coil both are same. In the real time situation it is not so, because there is some loss due to resistance of the coil, there is some loss due to eddy currents. Okay, so there are some losses, and hence input power is more than output power, which is obvious condition. One more thing, this ratio ns by np decides if the transformer will be step up or step down. If it is greater than 1, means number of turns in secondary coil is more than that in primary, then the transformer will act as step up transformer. But if you see that ns by np is less than 1, then the output voltage will be less than input voltage, and then it is called step down transformer. Okay, this ratio is called transformer ratio. So what is transformer ratio? Transformer ratio is ratio of number of turns in secondary coil to number of turns in primary coil. So that is all we need to know about transformer. This soft iron core which is placed between two coils is sometimes put in form of strips uh, to avoid or to minimize eddy currents. And sometimes the coils are wound on the two sides of a rectangular soft iron core. One coil primary it is here, secondary is taken on other arm. Sometimes it is preferred to have single eye-shaped iron core, and on the eye shape, primary as well as secondary, both coils are wound and the wires are insulated so they don't touch each other directly. So that is all about transformer. I hope you could understand, and this is the last topic of the chapter. Thank you.